welcome to another lesson. In today's lesson we're going to be adding and subtracting fractions, specifically adding and subtracting rational expressions, which means we're not going to have things like 2 over 3 plus 2 over 5, for example. Those would just be regular fractions. We're going to be dealing with polynomials, just like we've been dealing with multiply and divide. And so if you didn't attend the last class or you didn't watch the last video, what I mean is the LCD stuff, go ahead and do that now, because if you don't understand the LCD, you're not going to understand how to get the LCD for these questions. I will review it a little bit, of course, but I just want you to know that you should know that stuff going into this. So first of all, how do you add and subtract fractions? Well, you need to make sure that the denominators are the same first, and then we can go ahead and do it. In order to make the denominators the same, we need to use the LCD. So what it says here is once we have the LCD for the fractions, we multiply each fraction by the proper expression to get the same denominator, then we can add or subtract. So the steps we're going to follow are these. The first thing we're going to do is to find the LCD, and we'll do that the way that we did it in the previous lesson. And the second step, and we'll see this in a second how it works, is we're going to multiply each fraction by what's missing. And what I mean by missing is once we make our LCD, some of the terms, for example, the bottom, might be missing a term compared to the LCD. So we're going to need to multiply to make it the same. And let me show you what I mean. First of all, LCD. What's our LCD for this case? Maybe pause the video, see if you can figure out what the LCD is. When I look at this, I look at my numbers. I have a 3 here, a 1 here technically, and a 3 here. So my lowest common multiple of my numbers is going to be 3. That would be my lowest common multiple, and in this case, lowest common denominator, the LCD, that's how I need to find it. I did that in the last class. Now, in the second case, our next set of letters, R's, we notice that the biggest group is R squared. Okay, so we have R squared. So maybe I should say LCD in black. Our blue stuff, our lowest common multiple, lowest common denominator is 3. Our groups of R's, what's our biggest group of R's? It's the 2. And then we look for our next letter, which is S's. The first group has no S's, the second group has 3, the last group has 1. Our biggest of those groups is S3. So our lowest common denominator needs to be 3R squared S cubed. So we found the LCD. Now we need to multiply each fraction by what's missing, and that can be like sort of the tricky part. So let me zoom in a little bit. I'm going to rewrite these fractions just to give myself some space, okay? So 2 over 3 R squared plus 4 over R S cubed minus 5 over 3S. These denominators are not this. None of those are the same. What we need to do is you need to multiply on top and bottom by something that would make it the same. So look at this. We have a 3 that matches this 3. We have R squared that matches this, but it doesn't have an S term. It doesn't have an S cubed. So what we need to do is multiply on top and bottom by S cubed. All right, that will eventually give us the same denominator, because if you look at the denominator now, it'll give us 3R squared S cubed, which is the LCD, and we need the LCD on bottom for all of these. For the next fraction, we don't have a 3. So what I'm going to multiply by, I'm going to multiply by 3 on bottom, and then of course on top. And what else am I going to multiply by? Well, it's also missing 1R, because this is an R and this should be R squared for the LCD. So I need to multiply by 3, I need to multiply by an R, and my S's, if you look at the S's, I've got 3 S's, my LCD has 3 S's, I don't need to multiply by anything there. So I need to multiply by top and bottom by 3R. My last situation, 5 over 3S, this one here, it's got a 3, it's got no R's, and it only has 1 S. So I need to add the 2 R's on top and bottom. I need to add 2 S's on top and bottom. Just in case you missed that, look, it doesn't have an R. It needs to get 2 of them, which is why I've added R squared. It already has an S, but I need 3 S's. So I needed to add two s's on top and bottom. Because look at this, s times s squared gives s cubed, which is what would give me the LCD. So let me multiply this out so you can start to see the method to my madness here, because maybe it can be a little tricky the first time around trying to figure out why I'm doing what I'm doing. So the next step, multiply everything, top and bottom. So 2s cubed over 3r squared s cubed plus 12r over 3r squared s cubed. Notice I'm just writing numbers first, then letters in alphabetical order. Minus 5r squared s squared over 3r squared s cubed. And notice how nice this is now. The denominators are the same. They have common denominators. The denominators are common, which means it's an LCD. Now let me just fix this up for a second. I just wanted to make that a little more clear. So now that I have those groups, look, if they have common denominators, we are allowed to add and subtract the top. So just take all the top terms. Let me just give you a side example here. If you had 1 over 2 plus 3 over 2, if you had the same denominators, then you're allowed to add the tops, right? 1 plus 3 over 2. And then you would simplify that down to be 4 over 2 or 2. But really, this is the key step here. You can add the tops because the denominators are the same. Same thing works for algebra. So take all the tops and add and subtract them. So 2s cubed plus 12r minus 5r squared s squared. And the bottom becomes one common denominator. It's the lowest common denominator. That's great. And then you simplify if you can. So can you simplify? No. S cubed r squared s squared. So there's no like terms on top. Can't simplify. That's okay. This question will be done. All right. So that is the method we're going to follow for all of this stuff. We're going to find the LCD, and then we're going to multiply each fraction by what's missing, and then at the end, we're going to group and simplify. But those are really the biggest steps. All right. So let's move on to the second one. Again, we're going to follow the exact same steps here. Notice that we have two different denominators. We have x minus 1 and x plus 1. So I challenge you now, I'll make a little space between our questions. Challenge you to pause the video, see if you can figure out what the LCD is going to be. Okay, hopefully you've paused the video and given it a shot. I see that we have a x minus 1 term, so that definitely needs to be in the LCD. And the other one has an x plus 1 term, which is different. So again, I have to take the largest group of a different factor. And in this case, we only have one of each, but that means that the whole bottom needs to be this. This is what we end up needing to have. So that's our LCD step, and our next step is we need to multiply by what's missing. So maybe you can set up this fraction yourself. I'll give us some space. We have a over x minus 1 plus a over x plus 1. What am I going to have? What am I going to have to multiply on top and bottom by to make the denominators the same? Well, the first fraction already has the x minus 1 term, so it would be a huge waste of time to multiply that again. It wouldn't help. But it does not have the x minus 1 term. So I'm going to multiply on top and bottom by that. So x plus 1 is what's missing. Let me write it in a clearer pen. X plus 1 on top and bottom, x plus 1. And notice here there's a problem. We don't have brackets. So I'll make a little note about that. Here, must add brackets. If you don't add the brackets, well, let me show you what would happen. If you don't add the brackets, as we see it right now, this would get multiplied out, which is not okay. We want the whole bottom here, the whole original bottom x minus 1 to be its own factor, and then it's multiplied by x plus 1. So we'll be adding brackets every time we do these multiplications here. So again, pause the video, see if you can figure out what we need to multiply on top and bottom here. First, you should notice that we need to add brackets. So I'm going to add my brackets in. And then on top and bottom, what is it? It's going to be x minus 1. And the reason I know that that's the correct order to do it, or correct method, is that you'll see here I have x minus 1 in both, which is part of my common denominator, and I have x plus 1 in both, which is also part of my LCD. And now we'll hopefully see that the bottom is common to both, which means we can add them. So I'm going to group them all up. I'm going to expand the tops, and I'm going to group them all up. So on the top of each fraction, I need to multiply through by a. So what this gives me is ax plus a. For the next fraction, ax first, and then a times negative 1 is negative a. I'm going to write the bottom as x minus 1, x plus 1. You'll notice that that's different than this. In this case, I wrote x plus 1 and then x minus 1. In this case, I wrote x minus 1 and x plus 1. There is no better method, like there's no correct way to do it. I'm just choosing one or the other. So I'm choosing x minus 1 and x plus 1, x minus 1, then x plus 1, just so that it's super clear that my denominator is the same. But I could have written it anyway, really. I could have written in the other order. So now I'm going to simplify the top. I can see here that I have ax plus ax, which is 2 ax's. I have plus a minus a, so a minus a, they're going to cancel. And then my final answer is going to be x minus 1 on bottom and x plus 1 on bottom here. That can't be simplified, and so that's as good as I can get. Now some of you might be a little bit confused as to how I got this top. So let me just add an extra step that you could have written if you wanted to. So I had an ax plus a. That was this piece here. But I could have written it all as one big fraction, right? So ax plus a plus ax minus a. And then the bottom would have been a x plus 1 and x minus 1, which I should have written more central there. So what you'll see now is that I have, once again, ax plus ax, that's 2 ax's. And I have positive a minus a, also known as a minus a. They cancel out. That's why my final answer gives me what it does. So this is just a kind of a little extra step here, in case you were wondering how I got what I got. And then that's how I get to the final answer. Hopefully that's clear. So again, as a recap, what I did was I looked at my denominators, I made my LCD from that, and then I said, what do I need to multiply on top and bottom to make that? So what do I need to add to x plus 1 to make x minus 1 and x plus 1? That's what I did. Then I multiplied through and added them all in one big fraction, and things were good. Let's try C. Once again, the same process is going to be followed, so the first thing I'm going to be thinking about is LCD. But we can't get the LCD until we consider the denominators. So this one, thankfully, is a very easy one. Look at the numbers first. So there's technically a 1 here, and we can see here we have a 2. So the lowest common multiple of 1 and 2 is 2. So LCD starts with 2. What about my letters? Well, I have A in both already, and the largest group of those is just 1A. So it's just the common denominator is 2A. That one was a really easy one to get, and hopefully that's clear to you. So what do we need to multiply each on top and bottom to make it 2A on bottom? Well, the first fraction is 1A. All we need to add is 2. So we need to multiply on top and bottom by 2. So the way I'm going to write that is I'm just going to treat the top in a bracket there, multiply it by 2, and on bottom I already had an A, so I'm just going to add a 2 to it. All right, so that's a really common shorthand to write it out like that. You don't need to write it out here and here if you can just put it here and make your life easier later. Okay, numbers usually come first, not after brackets, when you can. All right, the second fraction already has the lowest common denominator, so there's no need to change it. so no need to multiply by anything. It's already the LCD. So that's convenient. And now all we need to do is add them all on top. So I'm going to add a step that I don't technically need to show, but some of you might find it helpful. I'm putting everything I see on top on one big line, and now I can just simplify the top and see if anything cancels. So 2 times t and 2 times -3, that gives me 2t minus 6 minus t over 2a. Let's keep simplifying the top. We have 2t's minus t, it gives us a t minus 6 over 2a. And nothing can simplify there. So that's what we got. That's our final answer. So notice that some of these are quite simple. All I needed to do was multiply on top and bottom by this 2 in the beginning. And as a reminder, why did I multiply by the 2? Well, here I had 1a, right? There's a 1a there. There's a 2a over here. That gave us the fact that the common denominator was actually 2a. So all I needed to do to change the first denominator was multiply by what's missing. What was missing is a 2. And of course, if I add a 2 there, I needed to add a 2 on top as well, just to keep things balanced. Hopefully this is starting to make some sense to you. I'm going to do a lot more examples before this video is done, but if you get this, what I mean is if you understand the logic, you should be pretty okay for this topic. Now, before I move on to any more practice, and I really like you to pay attention to this, if you're still watching this part of the video. Some students skip through, but I do put wisdom in the video here. What is the difference between what I have to do for addition and subtraction and what I have to do for multiplication and division? Well, there's a huge difference. Addition and subtraction, the big rule of the day is that we need LCD, okay? For multiplication and division, let's just scoot back up there so we can show you that. For multiplication and division, there is no LCD. We don't need to worry about that. Nothing. All we need to do, if it's division, we keep flip, you know, keep the first denominator, keep the first fraction, change the sign, flip the fraction. If it's a multiplication, we just go ahead and factor it and then multiply things through. There's no LCD for multiplication and division. It just doesn't exist. So try to keep that in mind. The only thing you need to use LCD for is when you're adding and subtracting. Again, try to keep it in mind. I know students have trouble remembering that. Okay, let's do some practice. I would recommend you try these yourself. I'll show you all of them. And I'll show you the answers, but give them a good shot first. So the first one, this is what it looks like. I'll give you the final answer here. 5 over 2 and 2x minus 1. So give that a good shot. For E, once again, I'd like you to try E. The final answer for that, a little more complicated. Negative 3x minus 4 outside of x plus 2 and x plus 2. Some of you might want to write that as x plus 2 all squared. That's fine. And then for F, I'm not entirely sure if you're going to be able to get that on your own. Turns out it's actually not that hard a question, just different. This is the answer that you should get for this. So what I recommend you do is pause the video here and give them a good shot. Even if you only get the LCD, then you'd really be on the right track. I'm going to show you the entire question and how to do it, but it's really important that you at least give that a try yourself first, okay? So pause the video, take as much time as you need, and then come back here and we'll work through these. So let me erase these answers now. Let's take a look at the first one. Well, it's very difficult to figure out the common factor here, or I should say the common denominator, unless we have it factored. So that's the first thing we're going to do, and that goes back to what we did in the previous lesson. We factored first to make it obvious. So 2x minus 1, can't factor that. Second one here, 4x minus 2, pull out a common factor of 2. Leaves us as 2x minus 1. You should be able to see what the common denominator is here. We're missing a 2. Okay? In case you want to see it clearly, LCD, what's the LCD? Well, we have a 2, and we have an x, we have a 2x minus 1. Okay? Our numbers, we get our 2. Our 2x minus 1 is actually common to both, which is where this came from. So the common denominator is that you should hopefully see that all we're missing for that first fraction is the 2. So I'm going to add brackets, put 2 on top and bottom, and then simplify. So that gives us a 6. I know that that on bottom can just simplify down to this. We don't need to multiply through the brackets. In fact, you should never multiply through the brackets on the denominator when we're doing this stuff. It's just going to make it more difficult. And this is 2 outside of 2x minus 1. Now they've got the same denominators, we can add the tops or subtract the tops. That's 6 minus 1 equals 5. That one's done. Because 5 over 2 doesn't simplify to anything. There's no common factors, nothing fancy going on. This is done. I'm actually going to move this answer over here just because I think it's a little clearer. And we'll move on to the next one. What do we have here? Well, we definitely need to factor the bottom here to make sure we know what we're dealing with. So the first one, nothing to do here, but the bottom, what kind of factor is that? And by that I mean, what method are we going to use to factor it? That's a equals 1 form. That's a trinomial. If it's a equals 1, we can do it directly. Should be good at these by now. What two numbers multiply to make 4, add to make 4? 2 and 2. Both positive. Nice and easy. The next one, 3 over x plus 2, doesn't look like that can be factored. So the LCD in this case, it's going to be x plus 2 for sure, but it's actually it's going to be twice. Because even though it's the same factor, look, it's there once, it's there twice. If it's there more than once, our LCD needs to take both of them. And for the second factor, or the second fraction, it's already there once. We'll need to add it a second time in order to make the denominators the same. So add it to the bottom, we get x plus 2. Now the denominators are clearly both identical. They're common, and we just do the same on top. Okay, so I'm going to multiply through when I get to that. I'm going to group the top and bottom, okay? You can choose to group it all now or not. I'm going to keep them separate just because I want to make a point in a second here. X plus 2, that's my first fraction, minus, what's this? This is minus 3x plus 2. X plus 2, x plus 2. So something crazy, or should I say something a little bit tricky and difficult is going to happen. If you have a minus here on the fraction, it means you're subtracting everything on top when you do this. So the signs need to change. Let me show you what I mean. When you combine it all into one big fraction, so the denominator I'll just write out just to show you that it's all being combined now. The first term, this 2, we can write that down, that nothing changes. But it's minus 3x and minus 2. This is extremely important. So I'm going to say be very careful with your signs. If you want a little extra help on why that works, why does it look like this? Well, it's 2 minus 3x plus 2. Let me show you why it works. The fraction there is really dealing with subtracting 3x plus 2, right? Like that's really what's happening in this situation here. So if it's minus 3x plus 2, we got to change the sign of everything inside. Minus 3x and minus 2. And why is that? Well, it comes back to our basic simplification from, I think, Unit 1. That multiplies through, multiplies through. You can think of it as a negative 1, right? Negative 1 times 3x, what is it? It's negative 3x. Negative 1 times 2, what is it? It's negative 2. So be really careful here to know why the signs work out the way they do. But if you've got a negative in front of a fraction, you gotta change the signs on top. You don't touch the bottom, you never touch the bottom, but you gotta change the signs on top. All right, hopefully that's not too confusing for you. Let's simplify this final expression. I'll just shrink it down a little bit and let's see what we have for a final answer. Well, if my calculations are correct, oh geez, I see a little problem. Maybe you've been screaming at me this whole time. There is a glaring issue with one of the multiplications. I made a mistake that I always tell my students not to make. Do you know what it is? When I multiplied through here, I did 3 times 2 equals 6. Oh no! Let me fix this. I'll make it in a different color. 3 times x is 3x. 3 times 2 should be 6. That's a silly mistake on my part. So when I multiplied through the negative times the 6, it actually will carry through down here. It should be the 6. So sorry about that. Really sorry. I guess I wasn't paying close enough attention there. So I'll change my little note over here too. I guess it doesn't really make a difference, but just to be complete, it's going to be a 6 and turns into a negative 6. Sorry about that. Really should have paid more attention, but there's a lot going on in these questions, and we're all human, right? So let's simplify this. I'm going to say that I have my negative 3x. I like to put my letters first. And now I have 2 minus 6 is negative 4. So my final answer is going to be this. And some students would rather write it as simplified on bottom as possible. So this is what they could write. You've got 2 groups of x plus 2, so really you can write x plus 2 all squared. But it's equally correct for this course and the level at which we're dealing with it. It's perfectly fine if you leave it like that. Now, the last one. This one's a doozy, or at least it looks like it, but as soon as I tell you the trick for dealing with these, I think you should find it a little bit easier. So what's that trick you might be dying to hear? Well, you need to do like what's called a global, or at least I call it, a global LCD. Get to the LCD for all the denominators. What the heck does this mean? Well, look for your numbers first. I noticed that on all of these, there's just a denominator of 1, 1, 1. This is 1 over 1. So it's not really helpful to write out a number for the LCD. So let's look at our letters. Do I have x's? Yes, I do. I can see that I have x on bottom, x on bottom. So I've got an x. And what else do I have? I have a y on bottom. Again, I'm looking at all my fractions. So I have my y on bottom. My LCD is xy. And this is the trick. The trick is that you need to multiply every term by that LCD. So I say multiply every term by the global LCD. It just means the LCD for every single fraction here. So it's going to look crazy for a second, and then it's hopefully going to look easier. So I'm going to take this first term first. X over 7. I'm going to multiply that by xy. Okay. Minus y over x. I'm going to multiply that by xy. 1, I'm going to multiply that by xy. And y over x, I'm going to multiply that by xy. Just for clarity, I'm going to make those a slightly different color here. So this is what I'm adding. And now things will start to fall apart really quickly because we can treat it like 4 mini problems. Let's focus on this one first. On top, we have x and xy. On bottom, we have y. What cancels here on top and bottom? Y cancels on top and bottom. That'll leave us with an x squared. So I'm going to write out my fraction again. The first term, x times x, x squared. Let's do the same game for the second one. Y, x, y on top, x on bottom. What's going to cancel? X on top, x on bottom cancel. We're left with y squared. On bottom, what do we have? On bottom, we have 1 times xy. That's just going to leave us with xy. And the next term, we have y, x, y on top. We have x on bottom. What's going to cancel? The x is going to cancel again. And we're going to be left with a positive y squared. So I wish I could tell you that this question was done now, but once we group all this stuff together, the final step is always to try to simplify. So the way we simplify in this case is by factoring. So I know it might seem a little crazy, and this is why, and I should have said this at the beginning, this question here is definitely a challenge question. I wouldn't necessarily toss this just anywhere on a test. This is a challenging question. So how are we going to factor it? Well, thankfully it's not difficult to factor. The top is going to be a difference of squares, x squared minus y squared, and you should be really comfortable with that by now. That's x plus y and x minus y. If you're not comfortable with that, make sure you go back and watch the videos of those classes and do the worksheet. And on bottom, there's a common factor of y. That would leave us with x plus y. And now the top and bottom can cancel. X plus y, and we get this nice final answer, x minus y over y. So that's our completely simplified final answer. That is probably the trickiest question that there is on this sheet, just because of this whole global LCD idea. Now, there is another way to do this question, but you don't need to do it this way. I'm just showing you an alternate method, because some students, depending on who you are, you might prefer this method. But for now, just know that we're done all the new content for today's video. So if you really don't want to do a new method, this can be where you jump out and say bye-bye, and I'll see you next time. But for those of you that want a slightly different method that, who knows, might help you understand it better, this is where you should stick around and listen up. It'll only take a minute. So what I'm going to do first is I'm going to rewrite the original question. And you might remember when this was multiplication and division, what I did first was I rewrote it as one big line. So that's what I'm going to do here. I'm going to take the top, x over y minus y over x, and I'm going to multiply all that by the second group. Divide it by the second group, of course. Because that's really what's happening. We've got the first group here. Sometimes my highlights don't work. First group divided by the second group. There's nothing wrong with that. I haven't done anything wrong. I'm going to get common denominators for each of these groups now. So for the first group here, I know that I need xy on bottom, so I need to multiply the first term by x, and the second group by y. You can take some time to do that on your own if you want, but notice that the common denominator here, the lowest common denominator, needs to be xy, so the first group gets an x, the second group gets a y, and that's where that term comes from. The second step here, I'm going to do the same thing. The common denominator in this case is x, so the first term needs an x, the second term doesn't need to change, and that would group it under a common denominator of x. And now we have something that should look very, very, very familiar to something that we did before. This is the division of two rational expressions. So if we factor all these, we should be okay. So I'm going to do a keep flip flip on this. I'm going to go back to here. I'm going to do a keep flip flip, and then I'll start factoring. Keep that term, flip the sign, flip the fraction. Now we factor. First term, difference of squares. Bottom term, xy can't be factored. This can't be factored. This can't be factored. But now we can simplify something. We see an x plus y and an x plus y on bottom. Cancel that. What else do you see? Hopefully you can see that there's an x and an x. They can cancel too. What am I left with? I'm left with x minus y on top. I'm left with y on bottom. Box it, and you'll see that these are the same. Alright, so that is a tricky question. I wanted to make sure that I had it all done just so that you can see alternate methods of doing the same thing. The second method definitely takes a little bit more math skill and might not be for the faint of heart. But I wanted to give you two methods to approach this. And again, it's just a challenge question, so don't lose too much sleep over it. But if you understand this, you've got a really good handle on this topic. What we're going to do in the next video is just some mixed practice, okay? The mixed practice includes subtraction, addition, and then some multiplication. So what I'm going to do, I'm actually going to record an optional video for that, which I'll just treat almost like a worksheet video, so that you have some extra practice on it. But for now, that's the end of this lesson video. Have a great day!